Okay, welcome to today's chemistry class. For today, we're looking at chemical formula. So now, what's a chemical formula? Note that a chemical formula consists of a symbol or symbols showing the number of atoms in one molecule of an element or a compound. The key thing here is a symbol or symbols. So it can be a single which is existing as one, singular one, which is representing an element. Because an element is a substance which is formed by only one type of an atom. Example of an element is oxygen atom. So there we just have one atom. Unlike for a compound, which is formed by the combination of two or more atoms, which is representing what? Symbols. So now, a chemical formula, in other words, shows the number of atoms which are present in one molecule. For example, in water molecule. So for water, we know that water is H2O. This is a chemical formula for water, and this is a compound. But for just oxygen, this is just an element which is existing as a symbol, one. This is existing as a compound, which is showing symbols we have for oxygen as well as for hydrogen. Now, here a chemical formula shows symbols or symbols showing the number of atoms in one molecule of an element or a compound. So here we have one oxygen atom. There we have, for hydrogen, we have two hydrogen atoms and one oxygen atoms. Have you seen? A chemical formula is helping us to know the number of atoms which are present either in an element or a compound. I'm sure that's clear. If you're not clear, then we have this example here. So now, here we have names. We have names of these same molecules. For example, we have water molecule. What's the formula? Is H2O. What does this mean? This is a chemical formula for water, which means we have two hydrogen atoms. We have two hydrogen atoms and one oxygen atom. Let's go to carbon dioxide. So carbon dioxide, the symbol is CO2. What does this mean? This is a chemical formula now. We need to know the number of atoms. Obviously, it's very easy to identify the number of atoms that are present in one molecule of an element or a compound. So we have one carbon atom and we have two oxygen atoms. Let's go to methane, which is CH4. Here, what does this mean? This is a chemical formula now. So we want to know the number of atoms which are present. How many atoms are there for carbon and how many atoms are there for hydrogen? So for carbon, we have one, and for hydrogen, we have four. Let's go to ammonia. Ammonia, it's NH3. So how many atoms there you see? So we have one nitrogen atom as well as three hydrogen atoms. Let's go to table salt, which is sodium chloride. So there, sodium chloride, we have one sodium atom as well as one chlorine atom. As simple as that. I'm sure you're clear on that one. So now, what's next? We need to know now steps to consider when writing a chemical formula. Steps to consider when writing a chemical formula. So what's the first step? So the first step, you need to write the symbol for the combining elements and radicals. We need to write a symbol for the combining elements and what? Radicals. For example, if you're writing the symbol, like let's write for water. Water, yes. So now we need to write the symbol. What's in water? What forms water? We know that in water molecule, we have hydrogen and oxygen, like that. Now, that's the first step. Just writing the symbols, it's okay. You're okay, just like that. Now, what's the next step? Second step, write the variance of each element or radical at the top right hand side of this same element or radical. So now the valence, the key part is the valence. What's a valence? A valence is the number of electrons gained or lost in a chemical reaction, or is the number of electrons that an element loses or gains. So for example, what's a valence for hydrogen? Hydrogen, the valence is 1 and it's placed around on the periodic table. It has 1. So we need to write that valence now on the top. They are saying on the top right hand side. So top right hand side for hydrogen, we are going to write 1 on top there. And then for oxygen, how are we going to know the valence for oxygen? Oxygen is placed in group 6. Therefore, the valence is 2. You can ask where it's coming from. Where is it coming from? So note that on the periodic table, for group 1, 2, and for group 1, 2, and 3, if if an element is placed in group 1, the valence is 1. If an element is placed in group 2, the valence is 2. If an element is placed in group 3, the valence is 3. That's the number. But not for group 4, 5, 6, as well as group 7. For these 4, 5, 6, and 7, you need to subtract from the total number of groups, which is 8. So oxygen is in group 6. We will subtract from 8. So the valence is 2. So for group 4, 5, 6, and 7, we subtract from 8. Hope it's clear there. And then what's the third step? The third step, we need to exchange the valences of the combining elements and radicals by writing them at the bottom right hand side of an element or a radical. So we need to exchange the valence. So we're exchanging the valence for that one for oxygen, that will come down to hydrogen, and that one for hydrogen will come to oxygen. Again, the other thing not done, note that if the number is 1, what do? Do not write it. In some formulae, radicals are written in brackets followed by a small subscript. I'll show you this one, don't worry. So mostly radicals are written in brackets. Yeah, so now here we don't have any radicals. So if the number is 1, don't write. So we're trying to exchange. Step 3, we're exchanging. So we're doing this. So now we can see that 2 for oxygen is coming down to hydrogen, and that one, what's this statement saying us? If the number is 1, do not write it. So that's how water molecule is formed. Hope you are clear on this one. Now we can do some examples, but before that, let me show you some tables that you're supposed to know. This one, you don't even have to master, you just have to know the periodic table. If you don't know the periodic table, I have a video that explains how you can obtain valence on the periodic table. So you just have to ensure that you inbox me, I send you that video. Yeah. So now let's start. So a valence, what's a valence? I even explained a valence is the number of electrons that an element gains or loses in a chemical reaction. So now let's come to metals. We have metals this side as well as we have non-metals on the other side. So now let's start with metals. Name of a metal, potassium. Potassium is in group 1. I even said elements in group 1, 2, 3. If the element is placed in group 1, which means the valence is 1, which means it loses 1 electron for it to become chemically stable. If an element is placed in group 2, which means it loses 2 for it to become chemically stable. For an element to be placed in group 3, which means it loses 3 electrons for it to become chemically stable. So metals lose electrons, while non-metals gain electrons. So now, potassium is group 1, therefore the valence is 1. Silver is found between non-metals and metals. These are transition metals. They are variable valences. They change. They are not fixed. Unlike for these metals and non-metals, these other ones. So now silver, yes, the valence is 1. Sodium also is in group 1 as well as potassium. So the valence is 1. Copper has variable valences. The valence change is not fixed. Copper can exist as copper 1, copper 2, copper 3, just like that. And here are the symbols. So you need to know the symbols of elements. Please, you need to master this in chemistry. And you need to master the first 20 elements. Very important. Okay, and then let's go to these other metals which have the valence of 2. Barium is in group 2. Therefore, the valence is 2. Have you seen copper? We have copper here, copper 2. We had copper 1 there. I even told you, say, copper is a transition metal which is placed between which is placed between the metals and the non-metals. Those metals that are placed between metals and non-metals are the transition metals, and they are variable valences. The valences differ, they vary, they are not constant. Same applies to iron. It's found there also. We can have iron 1, iron 2, iron 3. Lead, you can have. So these are transition metals. Magnesium is placed in magnesium is in group 2. So since it's in group 2, what does it mean? The valence is 2. Let's go to mercury and zinc. The valence also is what? 2. Aluminium is in group 3. Therefore, the valence is 3. I told you group 1, 2, 3. When it's placed there, that's the valence. Lead is a transition metal. You can have lead 2, lead 1, lead 3, lead 1, just like that. And then That's all. So you need to master the first 20 elements. Now let's go to non-metals. So non-metals now, we have chlorine. I said now, from group 4, 5, 6, and 7. For this, when it's placed in group 4, yeah, you can get it just like that, because when you subtract from 8, it's still getting 4. 5, when it's in group 5, an element, which means the valence is 3. When it's in group 6, which means the valence is 2. Even oxygen was 2, you remember? Because you're subtracting these numbers. 5 from 8, we're getting 3. 6 from 8, we're getting 2. Those elements that are placed in group 7, you subtract from 8, you're getting the valence as 1. Have you seen what happens? So you need to master this. You need to know this. Yeah. So now, chlorine is in group 7. Therefore, the valence is also 1. Hydrogen, the valence is 1. Oxygen is in group 6. Therefore, the valence is what? 2. Sulfur is also in group 6. Therefore, the valence is what? 2. And those are the symbols. Let's go to nitrogen. Nitrogen is in group 5. Therefore, the valence is what? 3. So 5 you subtract from 8, that's 3. Then phosphorus, we have phosphorus 3 here. The valence is what? 3, just like that. We have also phosphorus 5. That's the valence is 5, just like that. Now, we need to know the radicals. Now, these ones, very much important. If possible, stick this on the wall, because you just have to know this. You just have to master this. When you master this, you become good at chemistry. I'm telling you, this is a proper foundation that I'm giving you. So now, let's start with the radical. What's a radical to start with? So these are groups of atoms that are incapable of existing as independence, as one. Mostly they are in groups just like that. But they have the what? The valence. So now we have ammonium, which is the formula, the chemical formula is NH4. And this NH4, it has a valence of 1. So these ones, you cannot find them on the periodic table. That's why I'm saying you need to have it stuck on the wall. You need to know this. If you are not good at memorizing, just stick it somewhere so that at least each and every time you're looking at this, because you just have to master. Ammonium, they like it. I'm sure you've heard of maybe potassium, ammonium carbonate, ammonium sulfate, something like that. So when you just hear that, that's a symbol, and the valence is 1. Chlorate, that's ClO3. We have chloride. Chloride, because of the ion for chlorine, the valence is 1. If you remember, and then we have hydrogen carbonate. So please master these ones. Hydrogen, and we have the carbonate, which is CO3. The valence is 1. And then we have hydrogen sulfate. So say a large cause, which is incapable of existing as one independent. And then the valence is 1. Let's go to hydroxide. This one, I'm sure you have heard of potassium hydroxide, magnesium hydroxide. This is hydroxide. So when you just hear hydroxide, that's OH. You need to master this. The valence is 1. And then we have the nitrate. Also, the nitrate is very common. I'm sure you have heard of maybe potassium nitrate, ammonium nitrate, all those things. So nitrate, so NO3. And then we have the nitrite, which is, there is a reduction in terms of oxygen. Nitrate is NO3, nitrite is NO2. You need to master that. You need to know that. So the ones that I want you to master, it's mostly ammonia. It comes a lot. The hydrogen carbonate, the hydrogen sulfate, these ones, the hydroxide, you master these ones, very important. Also, these other ones, you just have to know. Then the carbonate also, the carbonate, which is CO3, the valence is 2. I'm sure you've heard of calcium carbonate. This is a carbonate you're talking about, and the valence is 2. Then oxide, just oxide, the valence is 2, just like that. Then we have the sulfate. The sulfate is also common also. I'm sure you've heard of maybe sodium sulfate, potassium sulfate, something like that. So you just have to know this. And then we have the sulfide. This is the sulfide, yeah. And then the valence is 2. And then we have the sulfite, which is SO3. There is a reduction also. The sulfate, sulfate itself is 4. And then sulfite, obviously there is reduction. Same applies to nitrate and nitrite. You need to master this. And then we have the phosphate. I'm sure you have heard of maybe potassium phosphate, ammonium phosphate, all those things. So now you need to know. So phosphate is PO4 and the valence is 3. So these things you need to master. But on the examples there, when I'm solving, you just have to know these things. And please know also the carbonate master, the oxide. I'm sure you heard of calcium oxide. This know by heart, not by heart, please. Then let's go to the questions now. So what's the question saying? Write the chemical formula for each of the following compounds. So let's start with sodium chloride. Yeah, so if you remember the steps now, The first step was saying write the symbols for the combined elements or radicals. So sodium chloride, these are elements. You can find them on the periodic table. So let's start. What's the symbol for sodium? If you check on the periodic table, sodium is Na. Then chloride, that's Cl, Cl, like that. Now, what's the other thing? The next step was saying write the valence for the combined elements or radicals. You get? So now we're trying to write the valence for the combined elements or radicals. So now, what's the valence for sodium? Sodium is in group 1. So the valence is 1. Chlorine is in group 7. What does it mean? You subtract from 8, you're getting 1 also. Then you exchange, that's a third step. Once you exchange, what did we say? If the valence or the number is 1, what do? Do not write it. So that's how you write sodium chloride as a chemical. So quickly, let's go to potassium carbonate. So now, the first step, if you remember, we said write the symbols. So potassium now, this one is an element. You can find it in the periodic table. This one is a carbonate. You need to master it. You need to know it. You can't find the carbonate on the periodic table. No. So now, potassium, what's the symbol first? That's K. That's potassium. Then let's go to, let me just write it nicely so that you're able to, yeah. So, yes. So potassium is K. Yes. Then the carbonate, if you remember, it's CO3. Now, that's the first step. Second step, write the valence on the top right hand side. So we're writing the valence. So for potassium is in group 1, the valence is 1. Carbonate, if you remember, the valence is 2. Then first step, you need to exchange. So now when we exchange, the 2 there for carbonate is coming down, and then we have CO3. Now that valence is 1, so we don't even have to write it. As simple as that. Let's go to the third one. So see now, we're writing the chemical formula for ammonium carbonate. So ammonium carbonate, if you remember ammonium, that's NH4. Then the carbonate, that's CO3. And all these are radicals. You can't find this on the periodic. That's why I'm telling you need to master this by heart. So now, what's the valence for ammonium? On the table, you know the table, so you need to master this. That's 1. The carbonate is 2. Then you need to exchange. That's the third step. So now, once you exchange, just like that, the 2 is coming down. Now, when we can't just write 2 there, we need to. That's why they are saying most radicals are written in brackets. They're covered with blankets. If you remember that last point, there's a blanket thing with a subscript, which is these 2 now. That's a subscript now down there. So these 2 now, it's for hydrogen as well as for nitrogen. But when you write without the bracket, it just means maybe it's just for hydrogen. So you need to include the brackets, please. Even in my simple task, that's what I need to do. I don't want to see such mistakes, please. And let's write for the carbonate, CO3. We're done. That's how it's done. There, the ammonium is just giving us 1. And if it's 1, don't write it. So that's how you write ammonium carbonate. As simple as that. So let's go now to the fourth one. So the chemical formula for aluminium phosphate. So how do you write aluminium phosphate? So the first thing, start with the symbols. That's Al. The phosphate, if you remember, that's PO4. That's a radical and that's an element. Aluminium is an element, that's a radical. So now what's the valence for aluminium? It's in group 3. Therefore, the valence is 3. Phosphate, the valence is 3. That's a radical. Then we need to exchange this. So aluminium is having 3. The phosphate. So now you can do this first. Then you write the 3. But if the numbers are like this, they're the same, they're equal, which means you divide. So the final chemical formula for aluminium phosphate will be like this. Just like that. That's how you write aluminium phosphate. Let's do the last one. Calcium hydrogen carbonate. So how do you write calcium hydrogen carbonate? So we have this calcium is an element. You can find it on the periodic table, but hydrogen carbonate is not on the periodic table. So what do you do? So let's write the symbol. So that's Ca. Then hydrogen carbonate, if you remember, that's HCO3. So now, what's the valence for calcium? It's 2. It's in group 2. And then the valence for the hydrogen carbonate, that's 1. If you remember, then we need to interchange the what? The valence. So now, once you interchange the valence, so you have the calcium there. Since it's one, we don't have to write it. Then we have HCO3. Then the 2 is coming down, so we need to put it in bracket. Most of the articles are written in brackets like that, and then the subscript down there, just like that. So this is how it's done. I'm sure it's clear. So the next thing, don't forget to follow, subscribe, like, share, and what? Comment. And then for those who want to reach me out, those who want extra lessons, those who want to be assessed, those who are serious, those who want good grades, you can WhatsApp me on this number, or you can call this number for help. Lastly, thank you for watching.